All right, guys, 1A and C there. You just had to write those equations in standard form. So for the first one, remember standard form is that y equals mx plus c. So your first step would always just be to get the y term on its own. All right, it doesn't matter what's in front of that y term. You just need to get the y term on its own first. So that x you're going to have to move. All right, it's positive x on this side. So when you move it, it's going to become negative x. Okay, that's the first step there. Then you need to get rid of this negative 2. That's in front. So you're going to divide each term by negative 2. All right, now guys, what number is actually in front of x here? Negative 1, hey? So what is negative 1 divided by negative 2? Positive 1 over 2, hey? So that's where that half comes from there. That's actually because it is negative 1 divided by negative 2. All right, that's how I got that half. And then you have positive 8 divided by negative 2, which is negative 4. Okay, so that's the first one, 1A. Any questions on that one, guys? For 1C, again, you just need to get the y term on its own first. So everything else must move. So this negative x, when you move it, is going to become positive x. The negative 4 is going to become positive 4. And now what number is in front of y here? Negative 1, hey? So you have to divide each term by negative 1. So x divided by negative 1 is just negative x. And 4 divided by negative 1 is just negative 4. Okay, so it's negative x minus 4, that equation there. You didn't have to do B and D, so don't worry about those ones. Are there any questions on those first two, guys? Okay, for 2, you had to draw the graphs. There are the first two. All right, so for 2a, y equals 2 over 3x plus 4. This plus 4 is your y-intercept, hey? Here we go. There's my y-intercept, 0, 4. Yes? We all fine with that one? To get your x-intercept, you have to make y equal to 0. So you guys might have written 0 equals this whole equation, but it's the same thing, all right? I just wrote it the other way around. You should get x equals negative 6 when you solve for x there. So you might have written it like this. You could have said 0 equals 2 over 3x plus 4, right? You're making y equal to 0, so in the equation. Then you might have moved your 4 over. It would become negative 4. And now you're going to have to divide by 2 over 3. So to get that, I suggest you use your calculators. I don't know where my calculator is now. All right, but you would just type in negative 4 divided by, you can use the division button, 2 over 3, and then the answer will be negative 6. Guys, if you didn't write your intercepts in coordinate form, in point form, please add that now. You're not going to get the mark if you just write 4 and negative 6. You have to write the full point. For your y-intercept, x is always 0. That's something you must memorize. For your x-intercept, y is always 0. Okay, please. You have to know that. You plot them. So a y-intercept, so on the y-axis at 4, on the x-axis at negative 6. And then you connect your line, your 2 points. Okay, any questions on A, guys? For B, y equals a half x minus 2. The y-intercept is your C value, remember? So the C value here is negative 2. There you have your y-intercept. For your x-intercept, again, you will make y equal to 0 and then solve for x. So this whole thing is equal to y. So this whole thing, I'm making that equal to 0. And then you can solve for x and you will get 4 for your x-intercept. Again, you plot them and you draw your line. Any questions on either one of those two? Right, there we have C. Y equals 2x plus 1. So plus 1 is your C value. So that is your y-intercept at 1. Okay. For your x-intercept, you're going to make y equal to 0. And then solve for x. So for your x-intercept, you were supposed to get negative a half. And then you would just plot that. So you can see here, there I have 0, there is negative 1. So negative a half is just halfway there. And then you would connect those points. You can see D as well there at the bottom. The y-intercept is negative 3 because that's the C value. The y-intercept, negative 3. For your x-intercept, you just make y equal to 0. And this one is an easy one to solve. Hey, if you have a 0 there, you're just going to move the negative 3 over. And it's going to become positive 3. So your x-intercept for this one was just 3, 0. Okay, E was the one where I said you have to use the gradient intercept method because the C value is 0. All right, you can see here I wrote plus 0 in a different color pen. You didn't have to add that. That was just to remind you that your C value is 0. Okay, so your y-intercept is 0, 0. It's the origin. Remember, guys, when that happens, you have to do the counting thing. So the gradient is the number that's in front of x. If no number has been written, then we know that there's a 1. Okay, so that, remember, that's the second step of gradient intercept method. The first step is find your y-intercept, which is 0, 0. That's done. Second step is to write your gradient as a fraction. Now, guys, if your gradient is just 1, you're going to write it as 1 over 1. Okay, that means that from your y-intercept, you're going to count 1 up because it's positive 1 at the top of your fraction, and then 1 to the right because it's positive 1 at the bottom. Then there where you stop counting, you make your next point, and you would have to read it off there. All right, the coordinates of that point would be it's across from 1 on the x-axis and 1 on the y-axis. So that point is 1, 1. Okay, please remember you have to write those coordinates down. Any questions so far, guys? I see lots of people writing stuff down, correcting. So if you made mistakes, just make sure that you know where you went wrong, please. Okay, here we have f. Y equals negative x minus 3. The constant term, C value, is negative 3. So that is the y-intercept. For your x-intercept, you make y equal to 0. There you can see I made y equal to 0. All right. It would have been quicker if I had just moved my negative x over. Then it would become positive x. And then my answer would be negative 3. All right. Your x-intercept is negative 3 there. You then plot those 2 points and just connect them. Any questions on that one? Okay, let's look at G and H. Those are those funny ones. All right, I did help you with these yesterday. I told you what to look out for. If it's just y equals 4, guys, do you agree that this doesn't look like the standard form? Right, standard form is y equals, and then there's always an x. All right, this is just y equals a number. So that's how you would identify that this is a horizontal line. If it's just y equal to a number, all right, there's no x. It doesn't look like the standard form. So then you need to remember, we did these ones before we even introduced standard form. You need to remember that it's saying y is equal to 4. So the line must cut the y-axis at 4. And then it's just a straight line going through there, a horizontal line like that. Okay, for that one, you only have to show 1 point. For all the other lines, you have to show 2 points. Okay, but if it's just a horizontal or vertical line, you only have to show the point there on the y-axis. So if it's saying y equals 4, it's going to have a y-intercept basically of 4, and it's just going to go straight through there. Okay, if it's saying x equals -3, this one looks even more different from standard form. All right, standard form is y equals something with an x. This is now saying x equals a number. There isn't even a y. Okay, so that is how you must identify that this is a vertical line. It's saying x must be equal to -3. So this line only cuts your x-axis at -3. It has an x-intercept at -3, and then it just goes straight through that point. Okay, if you've forgotten how to do these, there is a video, there are notes up and everything on these lines. We did them before we even did standard form. All right, the last one was difficult, because you first had to write it in standard form, and it was quite a difficult one to write in standard form as well. But guys, you need to be able to do graphs like these. All right, you can get a graph like this in your exam. So remember, when you're writing something in standard form, first you just want to get the y term on its own. So you need to move that 2x, and it's going to become -2x when you move it. Now we need to get rid of the 3 that's in front of the y, so we're going to divide each term by 3. If we have -2 divided by 3, that's just -2 over 3. But 6 divided by 3 is 2. Okay, so guys, you have to do that first. That will be worth 2 marks. Okay, writing it in standard form. Then, using your standard form, you now are going to have to find your y-intercept and your x-intercept. The y-intercept is the constant term, which is 2. So 0, 2. For your x-intercept, you make y equal to 0. So you take this whole thing and you make it equal to 0. You then solve for x, and your x-intercept is then 3. You then plot those 2 points and connect them. Okay, we are talking about parallel and perpendicular lines today. So that is the next heading when you're done there. You can just copy that diagram, please, and we're going to discuss what's happening there. So guys, I hope that when you are looking at this picture, it might not be perfect, but oh, sorry, but those two lines are parallel, right? Can you see that? Do we remember what parallel lines look like? Remember we worked with them with quadrilaterals in all sorts of shapes and so on. All right, they run with the same slope. Okay, they're kind of going in exactly the same direction. So these two lines are definitely parallel. Okay, how did we indicate that lines are parallel again? What symbols did we use for that? CP? Yeah, or one arrow. Okay, remember we use little arrows on the lines. Okay, so let's do that. Let's use two arrows this time, just because you might get confused with those arrows on the ends. Okay, so those blue arrows are just showing that the lines are parallel. Now guys, a specific thing will always be true about two parallel lines, okay? And that is that they will always have the same gradient. Remember, what is a different word for gradient? We haven't really been using that word, but I think on the first day I wrote that gradient slash slope. Do you guys remember that? Okay, and lines that are parallel, they slope in the same way. Okay, they are equally steep. If we look at that, they have exactly the same slope. They're just in different spots, all right, but their gradients will actually always be the same. We are going to calculate the gradients now for each of these to make sure that that is true, all right? What is the name of this top line? If it's going from A to B, we can say that that line is called AB. Okay, so let's find the gradient of AB. So let's write it like that. The M for gradient with a subscript AB. Okay, because we have two lines now, so we need to indicate that we're finding the gradient of AB. And that is how we do it, by making a little subscript. Okay, gradient, remember, is change in Y over change in X. Do we have 2 points on line AB? Yes, hey? So let's take the Y value of this point, which is what? What is the Y value of this bottom point? 0 minus the Y value of the top point, 1 over X value minus X value. Okay, we've done this many times before. So we've done change in Y, so Y minus Y over X minus X. So -1 minus 0. I'll do it all in one line now. What do we get there? What's 0 minus 1? 0 minus 1? -1. Hey, and what about -1 minus 0? Again, -1. What is that? What's the answer there? 1. So the gradient is +1. Guys, do you see that it has to be positive? Right, it's an increasing line. It's going up. Okay, that's the gradient of AB. Let's quickly find the gradient of CD, and we're supposed to get the same answer, okay, because they are parallel. But let's see if that actually happens. The gradient of CD. Do we have 2 points on CD? We do. Hey, they've only indicated one, but look at what the other one is. The origin. Okay. Now, guys, they'll never put the coordinates of the origin next to it. They'll never actually write 0, 0. You need to know that the origin is 0, 0. Okay, just make sure that in the way that you've drawn it, that you've actually made a point there on the origin. Okay, there should be a point there. It's a bit difficult to see. Okay, so y minus y. What is the y value of the origin? 0 minus y value of that point, which is 1. Over x minus x. Again, 0 minus 1. What's 0 minus 1? Negative 1. Hey, so I'm going to get negative 1 over negative 1 again at the top and the bottom. And that is 1. Therefore, the gradient of AB is equal to the gradient of CD. Right? They're the same value, so they're equal. Therefore, AB is parallel. Do we remember the symbol for parallel? To CD. Guys, if they ask you whether two lines are parallel with these kinds of questions, with straight lines, then that is how you would do it. Okay, you would find the gradient of the one, then you find the gradient of the other. Then if they're equal, you have to say that they are equal. Therefore, they are parallel. Okay, that's how you would do it. Let's just write a little note here at the bottom. Parallel lines have equal gradients. Okay, any questions on that, guys? So maybe they'll tell you that one line has a gradient of 1, and they'll ask you, what is the gradient of a line that's parallel? Then you need to remember, parallel lines have the same gradients. So the other gradient will also be 1. Okay, they can ask it in different ways, but it's very important, guys, that you remember this. Parallel lines have equal gradients. Okay, let's talk about perpendicular lines. Perpendicular lines are different, okay, but we're going to summarize it in the same way. So perpendicular lines, do we remember what the word perpendicular means? They meet at 90 degrees. Hey, if two lines are perpendicular, where they cross, there's a 90-degree angle. Okay, so that's what we're going to show on our picture now, on our diagram. Okay, we're going to draw two lines. Both of those lines are going to go through the origin. Okay, so that's where they'll cross. That's the one line. It goes through -1, 1. Other line is going through 1, 1. And those two lines where they meet, that will be a 90-degree angle. So you can put your little block there to show that those two lines are perpendicular. Oh, let me again call these names, or these lines, let me give them a name. So let's call that one AB, and this one is CD. So guys, if we're just looking at those two lines, do we agree that their gradients can't be the same? Right? They don't have the same slope at all. If we're looking at AB, it's an increasing line, right? So the gradient of AB, we're not sure what exactly it is, but it's going to have to be positive, right? Do we agree with that? And then if we're looking at CD, that's a decreasing line that's going down. So this gradient has to be negative. All right, so there's no way that they can have the same gradient. The one has to be positive, the other one will be negative. And guys, that will always be the case for perpendicular lines. All right, one will have a positive gradient, one will have a negative gradient. We are going to write that down. Let's quickly calculate their gradients, and then we'll see what happens. So again, we're going to do the gradient of AB. We're going to do y minus y over x minus x. Okay, if we're looking at AB, let's start with the origin again. What is the y value of the origin? 0. So we're going to say 0 minus that y value, which is 1. So 0 minus 1 over the x value of the origin is also 0. Hey, minus the x value of that point is also 1. So again, 0 minus 1. Okay, and we calculated that at the top already. If we simplify that, we're going to get negative 1 over negative 1, which is 1. Okay, it's an increasing line. We're supposed to get a positive gradient. Now let's find the gradient of CD, which is the negative 1, and we'll see what that is equal to. Okay, we're going to say y value of the origin, because that's 1 point on this line, which is 0 minus that y value. So 0 minus 1 over x minus x. Okay, the x value of the origin is also 0 minus the x value of this point is now negative 1. Remember, when we have that, we need to put that in brackets. So at the top, I'm going to have negative 1 because 0 minus 1 is negative 1. And at the bottom, 0 minus negative 1, remember this becomes a plus. So this is actually 0 plus 1, which is just 1. What does that simplify to, guys? Negative 1. Now, guys, this is the rule for perpendicular lines. Okay, I'm going to write it here. If AB is perpendicular to CD, then, and this rule you have to memorize, okay? You're going to have to remember this. The gradient of AB multiplied by the gradient of CD will equal negative 1. Okay, that's how it works always. So if two lines are perpendicular, then if you take those two gradients and you multiply them together, it will equal negative 1. Okay, and we can see that here. What's 1 times negative 1? Negative 1, hey? Now, guys, this is very important. Highlight this or something. You're going to have to use this rule. We're not going to give you this formula. Okay, you're going to have to use this. They're going to give you one gradient and ask you for the other gradient. We'll do examples now, but this is very, very important. Please, I'm going to highlight it as well. If you don't remember this rule, you won't be able to do the questions. Okay, let's write down some questions so that you can see how we'll use this. If AB is perpendicular to CD and the gradient of AB is now 2, what is the gradient of CD? So guys, usually when they want us to find the gradient of a line, they have to give us 2 points, right? The way that we've calculated gradient all the time so far is we've done y minus y over x minus x. Do we have any points here now? They haven't given us any points, all right? They're telling us that our 2 lines are perpendicular. So as soon as we see that, I want you to write down this formula. Gradient of AB times gradient of CD is equal to -1. Okay, they're telling us that the lines are perpendicular, so we're going to use this formula. They want us to find the gradient of CD, right? That's what we have to calculate. But they told us what the gradient of AB is, 2. So let's write 2 in the place of the gradient of AB. Okay, they told us that M of AB is 2. So let's do that. 2 times the gradient of CD will be -1. Can I find the gradient of CD now? What must I do with that 2? What am I doing with the 2 on this side? I'm multiplying by it. What's the opposite of multiplying by 2? Dividing by 2. So that means that the gradient of CD is going to be -1 divided by 2. So -1/2. Okay, guys, very easy if you know that formula. Okay, if you know the formula, you just put the gradient that they gave you into the formula and then you divide -1 by that. Okay, that will always be the method. Let's quickly do one that's a bit more difficult, where the gradient isn't a whole number, where it's a fraction, just so that you can see. If I'm going to use some different letters now. If EF is perpendicular to GH and the gradient of GH is -3/2, what is the gradient of EF? Okay, guys, as soon as you read there that 2 lines are perpendicular, we need to write down this formula. I'm going to say gradient of AB perpendicular to, or sorry, gradient of AB times gradient of CD. What are the names that they've given us here? EF and GH. So those are the ones that I have to use. Okay, so we're going to say gradient of EF times gradient of GH is equal to -1. Okay, because they told us that they're perpendicular. So the gradients, if we multiply them, will have to equal -1. Yeah. Yes, always -1. Yeah. Okay, which one did they give us? GH. Okay, so let's put that one in. So we're going to say the gradient of EF multiplied by, now guys, because this is negative, you can put it in brackets just to make sure that you don't forget that negative, but it's also fine if you don't. Just make sure that if you're not putting it in brackets that minus is very clear. Okay, sometimes if it's a times and then a minus, you can maybe forget it. Now what's the opposite of multiplying by negative 3 over 2? Dividing by negative 3 over 2. Okay, now guys, you might want to use your calculator for that, because it's not so easy to just divide by a fraction always. All right, so get your calculators out. I don't know where mine is, and I don't want to use this one because it's different. All right, please type in -1. Then you press the divide button, and then you're going to type -3. You press the fraction button, and then 2. See if you can do that. What are you guys getting? 2 over 3. Well done. So the gradient of EF is then positive 2 over 3. Okay, guys, like I said, if two lines are perpendicular, the one will have a negative gradient, the other one will have a positive gradient. We see that in both of these, hey? In the first example, the gradient of AB was positive 2 and the gradient of CD was negative 0.5. Yes. In the second one, the gradient of GH was negative and then the gradient of EF is positive. Okay, guys, this formula, like I said, very, very important. Okay, you have to memorize that. And like Nobisa asked, it's always -1. Okay, it's not going to be a different number ever. It will always be the two gradients multiplied together equal to -1. Okay, any questions there, guys? I'm just quickly going to find an exercise for you so that you can practice this stuff. Okay, guys, I will post this on Google Classroom, these questions, but you can also take a picture of it if you want. This is called grade 9 maths tutorial. If you want to write it at the beginning, I just punched a hole through grade. So that's grade 9 maths tutorial. So please make that your heading quickly. Grade 9 maths tutorial. You don't have to write the whole thing. Yeah. Yes, yeah. Okay, guys, I want you please to do of this tutorial number 2. I also punched a hole through the 2 there, so that's number 2. All right, number 2, rewrite the following in the form y equals mx plus c, and then sketch them. Okay, showing intercepts with the axes. So I want you to do that. That's basically just another or some more practice on the stuff that you did for homework. If we're just looking at 2.2, there's a 4 at the bottom here. What will I do to get rid of that 4? What do you guys think? What's the opposite of dividing by 4? Multiplying by 4. So your first step in 2.2 is going to be to multiply each term by 4. Guys, do you remember this is actually an equation with a fraction, hey? What did we used to do with that? We spent a lot of time on equations with fractions. And you want to remember?
With the notice multiply each. So
by the 4 is you can just say the LCD. Yes. Okay. Remember, guys, when we are solving an equation with fractions, even if there's only one fraction, okay, we would have to multiply every term by the LCD, which is 4 in this case. So basically, you're going to multiply that by 4, which will then cancel out the 4 that you have in your denominator, right? You're going to multiply that by 4 and that by 4. Okay, then there's still going to be a negative 1 in front of that y that you must still divide each term by, okay, but you'll get to that. So I want you to do number 2. So that's 2 equations that you must write in standard form and then draw. And then I want you to do number 4 and 5. Number 4, determine whether the following pair of straight lines will be parallel or not. It is not sufficient to just say yes or no. You must show the working to support your answer. Guys, what did we just learn about parallel lines? They have the same gradient. Okay? Parallel lines have the same gradients. So what do we have here? Are these lines drawn or written in standard form? No. So that's what I suggest you do first. Take both of these equations, write them in standard form. And where do we find the gradient again in standard form? If y equals mx plus c, what is the gradient? M. Okay, so once your equations are written in y equals mx plus c, you're going to look at the m value for both of them. If they have the same m value, they have the same gradient, so then they will be parallel. Okay, so that's what you have to do for number 4. Write them in standard form, check, do they have the same m values? If they do, they're parallel. If they don't, they're not parallel. Okay, then for number 5, determine the equation of the line that is parallel to this, and that cuts the x-axis or the y-axis, sorry, at -2. Okay, that's a bit of a difficult one. I want you guys to see if you can do that. For number 5, just they've written this standard form in a weird way. They've written x over 2. How can I write that differently? Does anyone know? If I don't want the x at the top of the fraction, how can I write that differently? What number is that actually? Okay. A half. Okay, x over 2 is actually the same as a half x. So this equation, I'm just going to rewrite quickly, is actually y equals a half x plus 2. Okay. That's important. What is my m value here? What number is in front of x? A half. So the gradient of this line is a half. They're saying we must find the equation of a different line that's parallel to this one. And that different line cuts the y-axis. So has a y-intercept of -2. Okay, so you need to find the equation of the other one. All right, I'll leave that up there. Please take a picture of the ones that I've circled now with the little notes on the side. I will also post it on Classroom. But that is your homework for tomorrow. Return now, please.